In this video, we'll cover the problem implement queue using stacks. So here, we want to implement a queue using only two stacks. We can't actually use a queue under the hood. And we want to support four operations: push, peek, pop, and empty, or is empty, but here it's called empty. Push adds an element and returns nothing. Peek checks the top, or the kind of element that would next be removed from our queue, which basically means the element at the front. Pop does the same thing as peek, except it actually removes that element at the front of the queue and returns it. And empty is a boolean, returns a boolean that either says true, this is empty, or false, this is not empty. And in terms of the stacks that we use, we can only use push, peek, pop, size, and is empty. Now in JavaScript, we typically just use an array instead of a stack, because it kind of functions as a stack. So we don't really need to use size and is empty. We'll just check length and see how it compares to 0. Okay, I'm going to switch to the drawing because I want to kind of talk through how this is going to operate. Now, I've written out the operations that we have for our stack and our queue just so that we have some sort of framing. Okay, so first of all, I want to quickly look at how a queue operates. So we'll have a queue here. And let's say we've added the elements in this order, 5, 6, 7. Well, I'm going to number the things we would dequeue. So first we dequeue this, then this is gone, then we dequeue the 6, then these are gone, and then we dequeue the 7. Now, imagine we had a stack here. I'll call it S1 for now, or I'll just call it S for now. Now, it would have, okay, I'm going to draw it like this, just so that the S doesn't look like it's in line with everything else. So we have our stack. We have 5 and 6 and 7. Now the problem with the stack is that you can only access the top of it. And when we dequeue here, we want to return this 5 here. But in our stack, we would return the 5. So how can we actually get to the 5? Well, we can just pop everything on top of it and return the 5. We could just say pop until there's only one element and then return that element. But then we've lost our 7 and 6, who really should be stored in our queue kind of after the 5. Right? The way this would function here is we would remove the 5 when we dequeue, or I guess here they're calling it pop. And then we would have these remaining elements here. So we can't just get rid of the 6 and 7. What we can try doing is storing another stack. Now you can see why I was naming this S1, so we can have S1 and S2. So maybe we can pop the elements like we said earlier. I don't know if my eraser will. We can see. We can do this. We can pop the elements here until we have one left, and we can push them as we go. So I guess let's do this one at a time. Okay, we need a smaller eraser. Let's do this. So pop 7, and then push it here so that we don't lose it. And then pop 6, and push it here so that we don't lose it. And we could at this time just decide to pop the 5. Actually, though, an easier way we can do this is we just keep going. Pop the 5 and store it here. Now, one thing you'll notice is that before, when we inserted elements, the oldest elements were on the bottom. So let me actually write that. Oldest, oops, that is not a clear D, oldest on bottom. That's how the S1 was structured, right? We had our 5 at the bottom, which was the first element we added, then 6, then 7. Or you know what? Actually, we should frame this in terms of what's on top. So why don't we say newest on top, right? Because the latest element that was added is what's on top. So we'll say newest on top. The reason I'm framing this in terms of what's on top is because stacks are a data structure that's all about what's on top, because you can only pop and peek from the top, and you can only push onto the top. So the newest element was on top. But in a queue, we care about the oldest element. But you'll notice, whatever was the oldest element here is now going to be at the top of this stack, right? Because first we kind of moved this over. Oops, I don't know what happened there. We took this element and we moved it over. This was the newest element, and now that was at the bottom. Then we kind of continuously followed this until this element here, the oldest element, is on top. So you'll notice this is actually the newest element, And then this is the oldest element. So what this means is with our S2, we have the oldest on top. And that's the key. In a queue, we want to find the oldest element. And with our two stacks and the way we've done it here, our oldest element is on top of the second stack because we have flipped everything over. So now that we've done our flipping, if we wanted to pop from our queue or dequeue, we just grab the top of S2. And let's say we removed the 5, we want to do it again, we grab this, and we do it again. Oops. Then we can grab S2 and return that, and we can continue with this process. Now, what if we removed the 5? Actually, I guess we can truly erase this. So imagine we remove the 5, and then we inserted 2 elements. Let's say 8 and 9. So we insert 8, we insert 9. Then we continue dequeuing. We get our 6. I guess I can show what we're moving out here. So we have 5. Then we dequeue our 6. And then we dequeue our 7 here. Now we want to dequeue again, and S2 is empty. So we can't just dequeue from here, because remember, this is going to be the newest element on top, and that's not going to work. So we need to flip everything over. So you'll notice whenever S2 is empty and we want to kind of grab out whatever is at the front of our queue, we need to do our flipping. So we're going to remove the 9 from here and place it here. We're going to remove the 8 from here, and we're going to place it here. And now we can do the same thing as before. We can grab our 8. So we'll come here, we'll grab our 8, put it here. We can remove our 9, and we can put it here. And so what we've done so far has actually shown us basically these 4 operations. I guess we need a bit more space. Now, to push, we saw, okay, we just need to push into our stack 1. To pop, we saw, okay, just pop from the top of stack 2, but if stack 2 is empty, flip everything from stack 1 to stack 2. Same thing for peek. We can just peek from the top of stack 2, but if stack 2 is empty, we need to flip everything from stack 1 to stack 2. And to get this empty here, we can just have a size variable. Every time we push, we'll increase the size. Every time we pop, we'll reduce the size. Then we can just check if the size is equal to 0. And this is conceptually all we do. The key is that when we put elements in one stack and then move them to another, we are flipping them around so that we have this queue-like behavior in S2. So we're going to implement this in code, but I'm going to call these 2 stacks newest on top and oldest on top. So let's go ahead and see how we can do that. Okay, first things first, I'm going to switch this to use class syntax because that's what you should be using if you're in an interview. So we'll have our constructor here. We'll have a push method here that takes in x is what they're calling it. We might rename that. We'll have pop. We'll have peek. And we'll have empty. I'm not going to copy the annotations just because I'm lazy. Okay. One thing I'm going to do here is because we're not using a real stack and we're just going to use JavaScript arrays, there's no built-in peek on an array in JavaScript, and that can be a little bit annoying. So I'm going to write one up here. And we're just going to grab the last index of the array. So do array.length -1, and then we're just going to return array last index. And we have to do one other check, which is we can't peek into something that is empty. So we'll say if the length is 0, we'll throw a new error, and we'll say cannot peek, stack is empty. Okay, great. Now, in here, we need to initialize our state. So we need our 2 stacks. So we'll say newest on top stack is going to be this. Or I guess we can just name it newest on top. And then we can do oldest on top is our second stack. And then we're going to have our size variable, which will start off as 0. Whenever we get a new element to push, I'll call it new element, then we just need to add it to our newest on top stack. We saw that in our demonstration. It shouldn't be too bad. And then we should update our size accordingly. Now, when we pop, how did we do this? Well, let's see. First thing we should check is if the size is 0. If the size is 0, actually, we should not use that. We should use our empty method here. So we'll say if this.empty, we'll write the empty method later, but just kind of pretend it works for now. if we're empty, we can't pop. So we're just going to throw an error and say, cannot pop, queue is empty. Okay, now we know there are elements in our queue. So the easy thing is, if our oldest on top has something, we can just pop from it. So we can say, if this dot oldest on top dot length is greater than 0, or we could just do, if we're using a real stack, we would use the isEmpty method, but that's okay. If there are elements, then what we can do is we can say, first of all, we should decrease our size, and then we can just return this dot oldest on top dot pop, like so. This is the case where we don't have to do any sort of movement. Actually, there's going to be a nicer way we can write this, but for now we'll leave it like this. Okay, so if we already have an element we can return, we just return it. Otherwise, we need to actually do the movement from one stack to the other. So I'm going to write another method that does that just to separate our logic. So I'll say move to oldest on, or I'll say move elements to oldest on top. And this is just going to say take everything from newest on top and move it to oldest on top. Remember, we can't just use any array methods just like copying stuff. So we should make sure that we actually only use the operations we're supposed to. So we'll say, well, this guy, this newest on top, still has elements. So while the length is greater than 0, well, we should pop from it. So we should say element equals the result of popping this. And then we want to push our element onto this oldest on top here. So we're just going to push element. And this is all we need to move the elements to the oldest on top stack. So what I'm going to do here actually is I'm going to do the negative condition. So what I'm going to say is if we have nothing on our oldest on top stack, so if its size is 0, only then do we need to do this movement here. So then we'll say do our movement. Move everything onto oldest on top. That way, this logic is going to look a lot cleaner. So we know that at this point we must have elements on the stack because we know we're not empty, and we know that either we already had stuff in oldest on top or we just moved stuff onto oldest on top. So then we can just decrement our size and then return the result of popping from oldest on top, which must be the oldest element since it's oldest on top. And we just moved everything to it, if need be. And what we care about in a queue is the oldest element. So that's great. That's exactly what we want. Peek is going to be very similar behavior. We are going to say if we're empty, throw a new error and say cannot peek, queue is empty. Otherwise, we will say, yeah, very similar to logic to before. We can say if there's nothing to peek from here, then we need to move everything to oldest on top. Now, if we reach this point, we know that we are not empty. Like we have some elements, and there must be at least one element on the oldest on top. So we can just return peek. I'm gonna use our function from here, and we'll just pass in the oldest on top array, and that should give us whatever is on top there. Okay, the last thing we need to do is check our empty here, and this is going to be very easy. We'll just return whether or not the size is equal to 0. If the size is 0, we return true, we're empty. Otherwise, we return false, we're not empty. Okay, let's go ahead and test this out and see if I missed anything. Okay, it passes here, and if we run or submit, okay, great. It looks like it passes all the tests. Okay, that's all for this video, and thank you for watching.